In this video, we're going to talk about squaring binomials. For example, let's say we have the binomial a plus b, just a simple binomial, and we want to square this. What do you think that would come out to be? Well, I have a lot of students say that comes out to be a squared plus b squared. What about a minus b? What do you think that comes out to be if we square it? Well, I would have a lot of students tell me that that's a squared minus b squared. And what do you think? Before I tell you. Well, unfortunately, neither one of these is correct. Okay, and we're going to talk about why. Why is that? Well, first of all, let's look at an algebraic way to think about this. A plus b squared. Well, that means a plus b times a plus b. Now, you should have some practice at this point multiplying binomials. So when we multiply binomials, we're going to distribute a plus b into each of these things. So we're going to do a plus b times a plus a times b, or excuse me, a plus b times b. And then we'll distribute this a into the first parentheses and this b into the second parentheses, and we get a squared plus ab plus another ab term plus b squared, and we can combine those two ab terms together for a squared plus 2ab plus b squared. If I have a minus b quantity squared, let's do that the same way. A minus b times a minus b. Now in this one, let's use something that maybe you've learned before called FOIL. First, outside, inside, last. Now you could certainly do this same bit we did in the a plus b squared. By writing it out and distributing it, you will get the same thing. FOIL is just a shortcut of doing that distributing. So we would get a times a is a squared. A times negative b is negative ab. Negative b times a is also negative ab. And negative b times negative b is positive b squared. Combine like terms, and we get a squared minus 2ab plus b squared. All right, so algebraically we can see what the square of these binomials would be. Now let me give you another way to really remember this. And so let's start with a number version, all right? So let's say we had something like 4 plus 2 quantity squared. And let's say I asked you to simplify that. Well, by the order of operations, what would you do first? Yep, you would do the 4 plus 2, and you would get 6, and you would square that, and then you would get 36. Now I want you to notice this is not equal to 4 squared plus 2 squared. 4 squared is 16, 2 squared is 4, and that comes out to be 20. All right, so this is a very simple way. If you can't remember whether a plus b squared is a squared plus b squared, just put some numbers in and see if it works. It doesn't work. Now what you might be thinking about is if you have a times b and you're squaring that, yeah, that is a squared times b squared. Because what you're really doing is you're taking ab times ab, a times b times a times b. You can rearrange these terms and come up with a squared plus b squared. But when we have this plus in here, you cannot just do a squared plus b squared. Now let me really drive this point home by looking at 4 plus 2 quantity squared in a different way. So as we saw, by using FOIL or distributing, a plus b quantity squared is a squared plus 2ab plus b squared. Now let's look at this 4 plus 2 squared in a geometric way. We know this comes out to be 36, right? Because we did it up here. We did our order of operations. So let's look at it thinking about the area of a rectangle. So here I have, or a square in this case, some squares. So here I have a square of length 4 by 4, and here I have another square of length 2 by 2. And then these other sides over here, this is 2, right? And this is 4. So this whole distance right here is 6. And this is 4 right here. And this whole distance is 6. So what this is modeling right here is 4 plus 2 times 4 plus 2, right? The area of this square is 4 plus 2 times 4 plus 2. That's this side times this side. All right, so if we FOIL this out, if we write, let me write this out. If we write 4 plus 2 times 4 plus 2, because that's what 4 plus 2 squared means, and we FOIL this out, so the first thing we do is 4 times 4, which is 4 squared. And then the next thing we do is 4 times 2. All right, 4 times 2. And then we're going to have another factor of 4 times 2. And then we're going to have our last factor of 2 times 2. 2 squared, and we'll add that. Okay, there's our first outside, inside, last. Now, can you see these 4 terms in the picture? Where is this 4 squared? Well, it's right here. That's the area of this square. Where is this 2 squared? That's right. It's right here. Where is this 4 times 2? Well, you could put it here if you want. And then the other 4 times 2, or 2 times 4, commutative property, we could write it either way, is there. All right, so this bit right here ends up being the 2AB part. Let's show this a little more generally. Actually, before we do that, let's just see how this comes out to be 16 plus 8 plus 8 plus 4, which is 16 plus 4 is 20, 8 plus 8 is 16, so that gives us the 36 that we came up with by also using the order of operations over here, doing what was inside first and then squaring it. So we could look at this geometric model in general terms by making the sides of the green square A and the sides of the red square B. So then the sides of the big blue square are A plus B, and this is A plus B. All right, so if we want the area of the big blue square, that's A plus B quantity squared. All right, well, what is that area? Well, this piece right here has area of A squared. This piece right here has area of B squared. This piece is B times A, and this piece is also B times A, or you could write it as A times B, or AB. So if I want the total area, it's going to be A squared plus 2 of those ABs plus B squared. All right, so whenever I see a student, for example, we see this a lot. Let's say they're given the prompt to, oh, let's not write simplify. Let's write expand or multiply. They're given the prompt to expand. Oh, I don't know, how about x plus 4 quantity squared? And if I had $1 for every time I've seen this, I could retire and live on a private island. But what we need to remember is that we need to FOIL that out. FOIL that out. So we'll end up with x squared plus 4x plus 4x plus 16. We need this bit right here. That's these rectangles that we would be leaving out. All right, so whenever I see somebody make that mistake, I always picture that they only have part of the product. They're missing this part right here. They've lost part of their area when they make that tragic mistake. All right, so you can also follow the pattern. Follow this a squared, so that's x squared plus 2ab, all right, 2ab. So what is that telling you to do? It's telling you to multiply these two things together. This is a, this is b, and double it, all right? So a times b is 4x, and if I double that, I get 8x. So that's a little bit of a shortcut, plus 16. All right, so I hope this video helped. This is one of the top 5 algebra mistakes that I see over and over and over again, but hopefully this visual will help you to never make that mistake and to always square your binomials properly.